Hello friends, in this very lesson of modular arithmetic, we're going to be looking at another basic operations under modular arithmetic, which is multiplication. Now, in our previous lesson, we looked at everything on addition and subtraction. So in this very lesson under basic operation of modular arithmetic, we're going to be looking at multiplication. So we're going to be looking at the first worked example. That's the first worked example. So we have 2 times 3 in modulo 4, for example. How do we solve this? Now, it looks quite very much like the other operations, addition and subtraction, I beg your pardon. But this time around, this is multiplication of modulo arithmetic. So we'll talk about 2 times 3, in modulo 4. We could solve this really. Don't forget, if you look at this very two stars you're working on, they both fall among the set of digits that make up modulo 4. So we could create an operation table under this multiplication operation table, or we could just solve this directly. So let's solve this directly first. 2 times 3 will give us 6. So you're going to write 6 in modulo 4. What's that going to be? 2 times 3 is 6. So 6 to be written in modulo 4 is going to give us, so how do we do that? We're going to divide 6 divided by 4. 4 and 6 gives us 1, remainder 2. So 6 modulo 4 is 2 modulo 4. As simple as that. So 2 times 3, 6 in modulo 4 is simply 2 modulo 4. So quickly, let's create a multiplication operation table under this basic operations we're talking about. So don't forget, modulo 4, we have stuffs ranging between 0 to 3, 0, 1, 2, and 3. So on this y-axis, you have 0 also, 1, 2, and 3. If you have seen the previous lessons, you will understand and represent what we're talking about. So since you're talking about modulo 4, more or less like base 4, the digits range between 0 to 3. So on the x-axis and also on the y-axis, why we're talking about multiplication. So let's quickly solve this. 0 times 0 is 0. 0 times 1 is 0. 0 times 2 is 0. 0 times 3 is 0. So 1 also. 1 times 0 is 0. 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. So 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. Don't forget, when we talk about modulo 4, none of the results must be up to the modulo we're talking about. So 2 times 2 is 4. We can write 4 down. We're going to break it down. 4 in 4 is 1. So that gives us 0. 2 times 3 is 6. 4 in 6 will give us 1, remainder 2. So write down our 2. 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. 4 in 6 is 1, remainder 2. So write our 2 here. 3 times 3 is 9. 4 in 9 is 2, remainder 1. Write our 1 here. So the table is ready. There's a perfect table. So quickly, 2 times 3, let's see. Now, there's something I want you to observe. When it comes to addition and multiplication, our operations, our activities are commutative. When we say commutative, when you say A times B is the same thing as solving B times A. More or less like saying A plus B is the same is the same as B plus A. So commutativity is only closed under the addition and multiplication operation. But we don't have the same, we can't say the same for subtraction and division. So A minus B is not equal to B minus A. A divided by B is not equal to B divided by A. So when we talk about multiplication, this is what we have. So 2 times 3 virtually is the same thing as 3 times 2. It's the same thing as 3 times 2. So let's quickly look at it. 2 times 3, what are we going to get? 2 times 3 will give us 2. And also, when we look at 3 times 2 also, 3 times 2, that will also give us 2. 2 times 3 will give us 2. So whichever way you go, you're going to get the same result. So don't forget, it's the same thing. You got the same result when you compare it with the direct approach. So 2 times 3 modulo 4 is 2 modulo 4. And also when you use the table, 3 times 2 times 3 also is 2 modulo 4. As simple as that. So we're going to be looking at the second example right away. So let's look at the second worked example under multiplication operation. This is 15 times minus 9 to reach modulo 7. Now when you look at these two numbers you're working on, they are both bigger than the modular arithmetic you're talking about. This is modulo 7. The set of numbers that are expected to be, under modulo 7 are numbers between 0 to 6. So right here we have 15 and we have minus 9. So there's negative 9, but it's still bigger than the modulo we're talking about. So you're not going to be creating an operation table this time around. You're just going to solve it, use the direct approach for it. So 15 times minus 9 will give us 15 times minus 9 will give us minus 135. So minus 135 to be written in modulo 7. Let's see what we're going to get. So quickly we're going to be dividing. Don't forget, minus 135 over 7. We're going to be creating 7 times table going down the negative axis. 7 times 0 is 0. It's bigger than 135 minus. So 7 times minus 1 is minus 7. So if we run down, like, 7 times minus 20 is minus 140. Now before minus 20, if you do 7 times minus 19, let's see what we're going to get. 7 times minus 19 is minus 133, like this. 7 times 93 because C, sometimes 17 plus 6 13. So this minus 133. Minus 133 is bigger than minus 135. Minus 140 is smaller than minus 135. So we're going to settle for this. We're going to go with this. So 7 and minus 135 will give us minus 20 remainder. So minus 20. So what's going to be our remainder? We're looking for minus 135. And this is minus 140. How do we get a remainder? Minus 135 minus minus 140 will give us minus 135 plus 140. That will give us remainder 5. So you can see. So 15 times minus 9 in modulo 7 is equivalent to 5 modulo 7. That is a perfect result. Or if you don't want to use this approach, the other way we can, we could solve this. We assume that this is positive 135. That's a popular way we go about it. So 135 to be written in modulo 7. When we solve this, 7 135 will give us 7 times 19 is 133. 7 times 20 is 140. So we're going to go with that. 19 remainder. 135 minus 133 is 2. So we have 19 remainder 2. So 135 in modulo 7 is equivalent to 2 modulo 7. So if this is 2 modulo 7, what does it mean? It means minus 135 in modulo 7. So we read in modulo 7. We give us 7 minus 2 is 5. 5 modulo 7. The same result, different route. So this is the second worked example under multiplication. Now, we've come to the end of this very lesson. I'm very sure that you've gained one or two things. In the next lesson, we're going to be looking at division of modular arithmetic. Guys, don't forget, we are still working on basic operations. So we're going to be looking at division alongside multiplicative inverse. So if you gain one or two things from this very lesson, I would love you to subscribe to this very channel at EduMosaic and also follow me at Revelation Hub on Facebook and share this lesson also with others. See you in the next lesson. Thanks, bye for now.